J-Dot Solutions. Add-on desired.
Welcome to J-Dot Solutions. My name is KB Mallikarjun Rao. We are now going to deal with one of the most beautiful topics of coordinate geometry, namely straight lines. By the by, what is a straight line? Observe this. What do you say about this? Curve, 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 curve. But among all these, this last one has one peculiarity. What is that peculiarity? Like here, if you take 2 points on this curve and join them, do you say that the segment joining these 2 points taken lies entirely on the curve? No. So it's just a curve. I am putting you the same question. Take 2 points here. This is 1 point, this is 1 point. Join them. Are you able to say that the segment lies entirely on the curve itself? No. For this, no. For this, no, absolutely no. But for this, take 2 points, anywhere you like, and join them. The segment is entirely lying on this one. This is a straight line. What about these? These are just curves. So basically, it is also a curve with a specific character. What is that character? If you take any 2 points on it and join them, the segment joining them entirely lies on itself. That is a straight line. That is the beautiful definition of the word straight line. Okay, well, what will be the equation of a straight line? In what shape we can use and assume? That is the next matter for us to discuss. We all know that every equation of first degree in x and y definitely represents a straight line. Ax plus by plus c is equal to 0. Is it correct? Should we believe it? Okay, you don't believe, you can prove. Take 2 points x1, y1 and x2, y2 on this one. The locus represented by this equation. Then automatically we have ax1 plus by1 plus c is equal to 0 and ax2 plus by2 plus c is equal to 0. It is an easy matter to show that the segment joining those 2 points entirely lies on this. How to prove it? Very simple. Take a point which divides these 2 points x1 y1 and x2 y2 in the ratio k is to 1 and get it substituted. It's very simple. Okay. So we have enough theoretical background about the same. So we declare that x plus by plus c is equal to 0 is the general equation of a straight line. Okay. Now, let us now focus our entire attention on different types of straight lines. How many types of straight lines we can discuss with? Observe this. These are horizontal lines. Observe this. These are vertical lines. Observe this. These are inclined lines. Okay. Altogether, 3 types of straight lines we can discuss. Horizontal line, vertical line, and inclined lines. Okay, let us spare time separately for these 3. Well, horizontal lines. The first line, which is the representative of all horizontal lines, is x-axis. We know that equation of x-axis is y is equal to 0. how to believe this? Why is it necessary to believe that equation of x-axis is y is equal to 0? You take any point on x-axis, y coordinate vanishes. So y is equal to 0 is the condition satisfied by each and every point on x-axis. That is why equation of x-axis is y is equal to 0. Good. Take a point, take a line parallel to x-axis. Is also horizontal. Well, these two are parallel means at any position this distance remains same. Suppose this distance is k units. K units. What is the y coordinate of this point? K. What is the y coordinate of this point? K. What is the x coordinate? According to the distance, we will frame the x coordinate. So for any point on this line, y coordinate is k. Hence, equation of a line parallel to x-axis is y is equal to k. Y is equal to k. Suppose a line is taken here. If this distance is some 4 units, this we say that y is equal to minus 4. Equation of a line parallel to x-axis at a distance of 10 units above it, y is equal to 10. Equation of a line parallel to x-axis at a distance of 6 units below it, y is equal to minus 6. In general, equation of a line parallel to x-axis is y is equal to k, where k is the magnitude rather the distance between that line and x-axis. If k is positive, the line is supposed to lie above x-axis. If k is negative, line is supposed to lie below x-axis. That's it. Well, like this we discuss with horizontal lines. Now let us turn our head towards vertical lines. What is the immediate vertical line appearing in this graph? Y-axis. We are sure to observe the x-coordinate of every point on y-axis is 0. Therefore, equation of y-axis we can write x is equal to 0. Just move a distance and write a line parallel to y-axis. As it is parallel to y-axis, this distance remains same everywhere. This distance is nothing but the x-coordinate of this point, every point. Hence, if this distance is k, hence equation of this line is x is equal to k. So, x is equal to k is a vertical line, that is a line parallel to y-axis. If you say x is equal to 2, equation of the line parallel to y-axis and at a distance of 2 units to the right of it. If you say x is equal to 4, then we say that x is a line, the line is parallel to y-axis at a distance of 4 units to the right of it. Suppose you take x is equal to minus 6. What can you explain that? X equal to minus 6 is the line parallel to y-axis at a distance of 6 units to the left of it. Like that, by observing this discussion and previous discussion, x is equal to k is a vertical line and y is equal to k is a horizontal line. Nothing to discuss about these two lines so far. Hereafter, I mean, there is no necessity to trouble or to doubt of the equations of horizontal lines and vertical lines. Let us now concentrate on inclined lines. And the main concept to be discussed with the inclined lines is how to measure the so-called inclination. If this line makes an angle, say theta, with x-axis in the positive direction, then the theta is called inclination of the line. Well, what is the inclination of y-axis? 90 degrees. Actually speaking, you need not study the inclination. It is absolutely a vertical line. Thinking of it, discussing with it is merely useless. Okay, if next concept is slope. If theta is the inclination of the line, then tan theta is called slope of the line. What is the slope of the line? While discussing the slope of the line, one precautionary measure is to be taken. That line whose slope is under discussion must be non-vertical. Why? If it is vertical, how slopey it is a waste discussion. Isn't it? You see, this line somewhat slopey. This is having a higher slope, still higher slope. This is perfect vertical. Even the dictionary meaning tells us about slope is the amount of steepness of the line. To measure it here in the case of vertical line, it is foolish. That is why slope of a vertical line we don't want to define. Even if you applied this definition, say tan theta, for y-axis or for any vertical line, theta is 90 degrees, tan 90 degrees, you cannot have the answer. It tends to infinity, isn't it? So, slope of a line, if you want to use on paper, it must be non-vertical, and if theta is the angle made by the line with x-axis in the positive direction, then tan theta is defined as the slope, and the most general letter to represent the slope of a line is small m. Okay, good. We shall now remember equations of different forms of straight lines. Out of them, the first form, you can understand by looking at the diagram. We are ready to know equation of a line passing through origin having slope m. Everybody knows it. You need not prove it. Y is equal to mx is the equation of the line. Even if you want to have the proof, you take a point, say xy. Slope of the line is m. Answer is y is equal to mx. Is the first standard form of equation of a line passing through the origin, that is y is equal to mx. Why should you believe it? You see, in the very beginning itself, we have known ax plus by plus c is equal to 0 is the standard equation. If it passes through origin, what happens? If you substitute 0, 0 here, you will be getting c is equal to 0. Therefore, ax plus by is equal to 0. So this is the form containing only x terms and y terms. Even this contains only x terms and y terms. Okay. Not only that, one more formula is also there to have the slope of a line joining 2 points x1, y1 and x2, y2. What is the slope of the line joining 2 points x1, y1 and x2, y2? M is the slope. M is equal to, come on, y2 minus y1 by x2 minus x1. We have a very good theoretical support at our earlier classes. Slope of the line joining 2 points is y2 minus y1 by x2 minus x1, right? Good. Well, slope of the line is m. It passes through the origin. What is the equation of the line? Y is equal to mx. Suppose I give you is y is equal to mx. Its equation is now I give you the slope m is equal to minus 2 by 3. What is the line? Y is equal to minus 2 by 3 into x or 2x plus 3y is equal to 0. Okay, at this juncture, I would like to make you one particular habit. I want to see that this particular thing is habituated. What is that? Let me explain you. You observe the two forms y is equal to mx and ax plus by plus c is equal to 0. No constant. This passes through origin, this also passes through origin. Observe this. By is equal to minus ax or y is equal to minus a by b into x. Compare these two. What is the slope? Minus a by b. If the slope is minus a by b, you have to start with the equation as ax plus by is equal to 0. If the slope is minus 2 by 3, equation is 2x plus 3y is equal to 0. 2x plus 3y is equal to 0. If the slope is minus 3 by 5, 3x plus 5y is equal to 0. If the slope is 4 by 7, minus a by b is 4 by 7. So, equation is 4x minus 7y is equal to 0. If it is 4 by 7, we start with 4x minus 7y. If it is minus 4 by 7, 4x plus 7y. So, what I mean to say is, immediately after knowing the slope of the line, you must be able to trace 90% of the equation of the line except the constant. Of course, these are the lines which are under discussion, which pass through origin, so no question of any constant. Well, let us consider one more thing. Slope point form. One point will be given, slope will also be given, slope m. What is the equation? Simple, take a point say P. What is the slope here? Y minus y1 by x minus x1 is equal to m. You cross multiply, y minus y1 is equal to m into x minus x1. The most standard form of the equation of a line, but you see, we don't like to use this frequently. Why? Yes, let me tell you. Minus 2 by 3 and the point is 1 comma 4. What is the equation of the line? I don't want to use the formula. Slope is minus 2 by 3. I have to start with 2x plus 3y is equal to stop. Something must be put on the right hand side of the equation. That is of course the constant. How to guess it? A point is given, you substitute. 2 ones are 2, 3 fours are 12. 2 plus 12, 14 is the right answer. That's it. Within 5 seconds you can have the equation. Just like that. What is the equation of the line with slope m is equal to 3 by 5 and passing to the point 1 comma minus 2? Come on, slope is 3 by 5, so you can start with 3x minus 5y is equal to, substitute the point, 3 ones are 3 plus 10, 13. Like this. Okay, this is what we say about slope point formula. Okay.
Add-on solutions. Add-on desire.